Wow. Okay, so from the pre-calculus, we have x, we have y, we have the function, the exponential function, right? So let's say that this is let's say the y equal to 2 to the x power, then different colors. I'm using this one, that, maybe 6 to the x power. Okay, now the fraction. So let us using this is like this. Okay, so this will be, I'm not using function notation, which is f of x. So this will be 1/6 to the x power. Then this one. Okay, so this will be the fraction exponential form. Okay. All right, so then what's the e function? So e function is between 2 and 3 because e is about 2.7. .718, and there's more, 882, and keep going, right? So irrational number. So then between 2 and, in this case, 2 and 3, I mean the 6. So this will be, that's correct. So this will be, okay, so let us make that. All right, so what's the domain for this one? Oops. Domain or real numbers? Good. The range, range, positive, yes, good, thank you. So from 0 to infinity. We have logarithmic function. This is an exponential function. Okay, then we have logarithmic function. So we have this form, right? So in general, we have base b of x equal to y, if only if b to the, I cannot see, b to the y equal to x, all right? So this is like this. Let me draw here, since we have x, this is y, so this is log, this is also 1, right? So log base is like this. So this is y equal to, let me just using y, log base 2 of x, then log of base over 10. You can use that. Okay. Y equal to log base 10. So in general, we don't write down 10 there, right? So if we don't see any base, that means 10, right? But then how about natural logarithms, right? So that for logarithms spell, I have to be careful. So base E, right? So then we have between, in this case, between 2 and 10, base 2 and 10. So I will draw this way. So this is f of x, g over x, whatever is ln x. Okay, so if we have a base 10, we can write down this way. Ln x. Okay, this means log base e of x, right? Okay, so ln x means the base e. All right, so let me write down this one. What's the ln 1?
Zero.
Excellent. Okay. Now, can you see on the top, the y equal to f of x equal to e to the x? And then in the bottom, ln x, can you see that? They are inverse each other. So let me draw here. What's the domain in this case?
Zero to positive infinity.
Good. What's the range?
All real numbers.
Good. Excellent. Okay, so let me erase this one. All right, so we have e to the x like this. And then we have y equal to x, right? So inverse of function, they reflect about the line, which is y equal to x, right? So this will be like this. Okay, so this is, let's see, the g over x equal to what is called ln x, all right? So look, we have this one, 0, 1. And the coordinate is a swap, which is 1 and 0, right? So there is 1 and 0. Okay, so we have we had ln1, which is 0. Okay, now this is from the pre-calculus properties of logarithms and intermediate algebra. So properties of logarithms. So ABC is greater than 0, B cannot be equal to 1, R is any real number. The first one, log base B over AC. It's a multiplication, then we can split the addition. And second one, if we have quotient, Then we can split in subtraction. Now, if we have the power, which is exponent, so you might get confused a little bit, exponent and power. I mean, exponent with the exponential function. So let us use the power. Then we can bring down the power. Okay. So let us do just this one from the pre-calculus. So basically solve for x, right? So I just explain how do we bring the power. In this case, log base something, right? So let us take the ln both sides. Means that the natural log, okay? So we have ln 5, we can bring down the power down, okay? ln 2, x is here, so we divide by ln 5 both sides. So we have x equal to ln 2 over ln 5, okay? So this is the answer. You can do the log, you can do that, same answer we get, okay? All right. Let me erase this one. All right, so we're gonna do calculus stuff. So we should learn the derivative, right? So theorem 3.14, derivative of the natural exponential function. All right, so if we derivative e to the x power, then we get the e to the x. What a nice, right? But then we don't get this nice function. We always have a complicated function, which is a composite function. So then if we derivative e to the g of x, okay, then we just rewrite e to the g of x. Then we are using chain rule, which is g prime of x. Okay, so let us do that. Find the derivative. Rushing every time. Derivative of f of x equal to e to the 10 2x. All right, so we derivative, okay, always rewrite e to the function. So e to the 10 2x. Now we're gonna use chain rule, so 10 2x. So e to the 10 2x, what do you get? Derivative of tangent to x. Derivative of tangent to x.
Secant squared x.
Yes, secant square x, but we have a 2x, right? But then we have not derivative the variable yet. So we're gonna use the chain rule again. What do you get? Derivative of 2x.
2.
2. So let me write down in front, okay? So this is the final answer. Okay, how about second one? Number 1, number 2. So what is y equal to e to the x squared over x? How do we do? Y prime? What to do?
Quotient rule.
Quotient rule, very good. So we're gonna use f over g, which is f prime g minus f g prime over g squared. So what do you get this one? F prime
2e to the x power.
Okay, so let us do that. We need to write down the function, right? Exponential function as it is, right? So e to the x squared. Now we're gonna use a chain rule. So that, right? Then g, which is x, right? Then minus f, which is e to the x squared. And g prime, what do you get?
1.
1. So you don't write down 1, that's good. It's okay. So x squared, right? Now, what is the derivative of x squared?
2x.
Yes, so 2x here. So let me write down 2x here. And then we have another x, right? So let us do 2x squared e to the x squared minus e to the x squared over x squared. This is the final answer. Okay. Let me erase. Okay. All right, so this time we have the natural log function theorem. 3.15, the derivative of the natural logarithms function. X is positive, y equal to ln x. Then we derivative y. Then we get the 1 over x. Okay. We see x derivative, which is 1 over x. Okay. But if there's more than ln x, right? Composite function, then we are using the chain rule, right? So let's say that. How about ln y equal to ln g over x? Okay. Then we do derivative. Then look, 1 over x for ln x, right? So that means 1 over g over x. Can you see that? We bring down whatever next to the ln inside the function. Then we do chain rule, g prime of x, right? Okay, this is how we do. Okay. Find derivative. And then x cubed plus 3x minus 4. Okay. All right. So with derivative, look next to the ln, inside ln, right? The function we're gonna bring down. So x cubed plus 3x minus 4. Then we are using chain rule, right? So d over dx, x cubed plus 3x minus 4. So derivative x cubed plus 3x minus 4, what do you get?
3x squared plus 3.
Okay, thank you. So this is the final answer. Okay, let us do one more. Let me slow down a little bit. So ln x squared sine x over 2x plus 1. Okay, so this one, we're gonna use the properties of log earlier. Quotient, then we make a subtraction. Multiplication, we make addition, right? Make sense? So we're gonna use that first, so by property. So this will be, and then the power we can bring down, right? So 2 ln x, multiplication, addition, and then ln sine x. And then division, we can use a subtraction, 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 which is ln 2x plus 1, okay? Now, in this case, we can do that, right? We're gonna derivative. So first term, first. How do we do? We derivative 2 ln x.
Is it 2 over x?
Excellent. 2 over x. Now, second term, we do derivative ln sine x.
Is the 1 over cosine x?
Okay, hold on 1 second. We need to bring down the sine x first, right? Make sense? Then we're gonna derivative using chain rule, right? On the numerator. Is it clear? Minus, let us do derivative of ln 2x plus 1.
So it would be the derivative of 2x plus 1 over 2x plus 1.
Excellent. Okay, so we're gonna use this one a lot. Okay, 5 stars. So please remember this one. And also earlier, the exponential function with derivative e to the x, e to the g of x, then e to the g of x times the chain rule, g prime of x. So there is a 5 stars as well. Okay, so let us finish this one. So this is 2 over x. And then derivative of sine x, what do you get?
cosine x.
Cosine x. And sine x minus derivative of 2x plus 1.
2 over 2x plus 1.
Over 2x plus 1. Okay, so you can simplify this one like a cotangent, right? Let us leave like that. Because we need the common denominator to make it simple. We skip that one. Let me erase this one. Okay, so 2 formulas today. Natural log, which is ln, right? And log ln x. So we must remember, okay, because we're gonna use a lot. Okay. All right, this one we use less. So you might have just in your note this one, okay? I don't want to memorize this one because if we memorize too much, then your brain cannot accept the other one. Just to know how to use the formula, how to apply the formula, that's it, okay? For this one. Logarithms make functions cannot be equal to 1. Okay, so if y equal to log base b of x, okay, then we derivative this one. How do we do? We bring down x, right? But then base b is the number, right? So we're gonna use ln b. It's a very similar way to ln x. Okay. Oops. Sorry. Oh my God. I dropped the pencil. Okay, so second one, we don't have nicer function like that, right? So we're always using chain rule. So second one, y equal to log base b of g over x. How about that, right? Then this is the same thing. Dy over dx. Same. 1 over, bring down g over x. Then ln b, right? Then using chain rule, so g prime over x. Okay. For example, Oh, did I? Oh. This is the formula. Okay. So if we have a base, any base with this form, then we do that, LMB. Okay. So let us do this one. Find the derivative of the first one, y equal to log base of x, y prime, what do you get? So let us just using the formula, 1 over x, right? Going down x, and then we change it to LMB, right? Let me show this one, okay? LMB, which is LM2. Here. Okay, let me show that. And just wait. Y equal to, we have, let me see which one I have. Log base 2 of 3x plus 4 y prime. We get 1 over whatever inside, bring down 3x plus 4 and ln 2. This is how we applied this one, okay? And let me show you, because your classmate curious about this one, right? So, okay, let's say that y equal to log base b of x, okay? Then this is the same as, look, I teach this way in algebra. The base to the other side, we get the x, right? So there is a b to the y equal to x. That is definition, right? Then we take the ln both sides. So b to the y power equal to ln x. Okay. Now, since we take the ln, we can bring down the power. So we have y ln b equal to ln x. Okay. Now solve for y. Then we get ln x over ln b. Okay. Now, we derivative. Then what do we get this one? We get dy over dx equal to, how do we derivative ln x?
1 over x.
1 over x. Then ln b is the constant, right? The number. So we keep that. Make sense? That's how we got. Okay. So how about second one then? Since I showed the first one, let us show the second one as well. So second one, we're gonna start y equal to b to the x. Okay, then we take the ln both sides. So we have y equal to ln b to the x. But look, we have experience. We can bring down the power, right? So we get x. All right. Then we do derivative. So with the derivative left side, derivative. So what do you get? Left side with derivative ln y. What do you get this one? Someone said something.
Is it 1 over y or no?
Okay, so 1 over y. Then dy over dx, right? We're using chain rule, right? Then with derivative the right side x ln b. What do you get?
Is it 1 over XL and B?
We get confused. So basically ln b is the number, right? There is no x. Can you see that? So ln b is the number, constant. Is okay.
Okay.
Yeah. Then with derivative x. So basically like this, 2x. With derivative 2x, what do you get?
2.
2. So what is the in this case then? With derivative
1.
ln b.
Oh, well, no.
Think carefully. What do you get?
Yeah, I mean, it would be 1, right? The derivative of x.
Derivative of x is the 1, but we have
Right.
constant there. So you say that if we
Oh, do we have to
x,
do the
then you said the 2.
Uh-oh.
Okay, I'm gonna say one more time. If we derivative 2x, you said that we have a 2, correct?
Correct.
And then we do derivative x ln b. Ln b is the x like 2. Then what do you get?
It's the constant.
It's a
So it would
constant.
just be so it would just be the derivative of ln b, which
It's
is
a
1.
constant.
Oh, constant is 0.
Ah! You said you said that you derivative, then we get the 2.
Right. 2x would be 2.
Yeah,
A
we have a
derivative.
constant x, so we derivative the ln b.
So it would just be 1, right?
ln b is the constant. So let's say the ln b like
Oh.
how about that?
So it's just
Do
the
you
ln
understand?
b.
ln
So
b
it's
is
just the
the
x.
constant. Yeah. So we
No.
derivative the x. That's correct. And then we keep
Right.
the coefficient there, right? So we derivative of x, which is 1 times ln b, which is ln b.
Just ln
Correct?
b, yeah.
Okay?
Okay. Yeah.
So let us solve for dy over dx. Then that is times y, both sides. Okay. Let me write down y in front so that we don't multiply. Okay. And that is dy over dx, which is y times ln b. Y is in this case b to the x power. Can you see that here? So we're gonna have a b to the b to the x power. Then we have ln b. Okay. Oh, this is not number 2. We will do this one. So we create another formula, right? It's okay? So if we have y equal to b to the square, b to the x power, then we derivative, then we get b to the x power and ln b. Make sense? So let me write down here. Let me erase, okay?
I have a quick question before you erase. For the second example, is it just 1 over 3x plus 4 times ln 2, or are we also supposed to take the derivative of 3x plus 4 for the
Point, yeah, good point. So we do derivative, okay? Makes sense. So we forgot, common mistake, right? We always derivative channel. Thank you.
You're welcome.
Thank you so much for pointing out. I don't want to release the mistake one. So what do you get?
Just 3 for the top
Just
part.
3, okay? So since no space, so I'm gonna write down just 3, okay? Thank you very much.
You're welcome.
Okay, 3. Okay, let me erase this one. And let me erase here. This is the second part from so if y equal to b to the x power, then we do derivative. Then we create b to the x, ln b, right? Okay, but we don't have always nice function like this. We have a composite function, more than one function. So if we have b to the g of x, then we're gonna use a chain rule. So this will be equal to, hold on one second, b to the g of x, we just rewrite, and then ln b, the base b, okay? So ln b means base b, so always we have a number there, right? Okay, we just using the variable for general things. Make sense? So this is the default one, this is the default one, okay? And number 2, number 4 is about the chain rule, right? Okay, I don't want to memorize this one. You can just know how to apply, all right? But then first formula, the exponential function, derivative of exponential function and logarithmic function, you must remember, okay? So let us do this one. If find derivative of y equal to 3x So we derivative 3 to the x power. Then we keep that 3 to the x power. Then the base ln3. Okay. If there is composite function 3 to the 4x plus 1, how about that, right? We derivative. Then we just keep right 3 to the 4x plus 1 and ln3, then chain rule, right? So we do derivative 4x plus 1. What do you get this one? No space.
Four.
It's a 4. Good. So we get, let me write down just a 4 there because no space. So I'm going to write down 4 here. So, which is derivative of 4x plus 1, all right? Okay, so let us do actual example. Let me erase this one. Okay, how about this? Find the derivative of h of x equal to 3 to the x power 3x plus 2. Okay, how do you derivative the function?
Start with the quotient rule.
Quotient rule, very good. Quotient rule. So f over g, f prime g minus f g prime over g squared, right? So we do f prime, what do you get? So let me see. Since this beginning, so let me write down for you. F prime, which is 3x prime, which is, we just rewrite, right? And then base ln3, right?
Yeah.
Okay. And g, which is, we just copy down. And minus f, g prime, now you can do it. 3 to the x power plus 2. Derivative of 3 to the x power plus 2. What do you get?
6x.
Hold on 1 second. So, okay, so we're gonna do 3 to the x, right? That is the first term, right? So, and then
Right.
the
Yeah, I
base
was
is
looking
3,
at the
right?
wrong one. Yeah.
The 3. Then that is the first term. And then second term has the 0. Can you see that?
Yep.
Okay. So we finish g prime. So this will be over g squared. Okay. So what can we simplify? So that's it, right? Yeah, I think that's enough because they don't have a common factor 3 to the x plus 2 to right side. Okay, so let us do this one. Find the slope of the tangent line to the graph of y equal to log base 2 3x plus 1 at x equal to 1. And we're going to find y prime first, then we substitute x equal to 1, right? So we did a lot. So how do we do this one? This is a little bit different ln x, right? Log base 2, but very similar concept. We bring down the function, right? 3x plus 1, okay? Then this time there is a base, so we're gonna keep that base, ln 2. Then we do chain rule, which is 3x plus 1. So what do you get?
Three.
It's a 3. Now, when x equal to 1, we plug in. So 3 over 3, 1 plus 1, ln 2. So what do you get this one? 4 ln 2. Okay, so this means same as ln 2 to the 4th power, which is ln 16. This is the final answer. If you're using the calculator, this will be 1.08.
Professor, is there supposed to be a squared on the derivative of h of x for the first problem? Not on
So
the top.
top squared?
Yeah.
Oh, no,
Oh, okay.
because this is f prime, right?
Yeah.
This is a g,
Yeah. Okay. Thank you.
right?
Mhm.
Mm. Okay, let me erase, and then let us do 2 problems, okay? Okay, so I'm gonna do this one. Find the derivative of y equal to x, so 3x. Okay, look, we never seen this one before. There is x, also there is x. Can you see that? Okay, then this is 3x, right? We know how to bring down the power. Okay, so take the ln both sides. But then let us save the step, right? So we bring down power first. So y equal to 3x ln x, right? Okay, now we're gonna derivative. Okay, left side, what do you get?
One over y.
So 1 over y, and then chain rule, dy over dx.
Oh, yeah.
And the right side, what do you get?
Is it just ln x?
Okay, so we're gonna use a product rule because there's x and then there's
Oh,
ln.
okay.
Can you see that?
Yeah.
F G, which is f prime g plus f g prime. So f prime. What do you get?
Just one.
1 and then g plus f g prime, and then she said already, right? 1 over x. Okay. Then this is 1, right? So we have that. Now we're gonna solve for dy dx. So we're gonna multiply by y. So let us multiply by y whole thing. So this will be dy over dx equal to y ln x plus 1. Well, what's the y?
Sorry, did we lost 3x?
That's correct, 3x. It's hard to say, huh? So 3. Oh! I see what you meant. We forgot 3. I omitted 3 there somehow. Thank you. Good eyes. So 3. So we're gonna make 3 there. And then 3x, correct? And then 3x, 3 ln x. How about we factor out with the 3, right? So there is a 3, factor out with the 3. Then there will be a ln, I mean the y, right? Okay. Then we have a 3 there. So we have a 3 there, and y equal to x to the 3 to the x power, right? Then this will be ln x plus 1. Okay. If we want to know about the I forgot to find the equation earlier. Oh, we got that, right? I'm crazy now. No. So what if we have when x equal to 1? We plug in everything. Can you please calculate this one? So we get 3, right? If we calculate ln1 is 0, there's 1, 3 times 1, which is 3. Okay, let us do one more. Let me erase this one. Okay, so we have this will be last one. Find the derivative of y equal to 2x to the 4th power plus 1 to the 10x. 10x is the power. So we take the ln both sides and we bring down power. Okay, then we do derivative both sides. Now, with derivative ln y, we have experience, which is 1 over y, dy over dx. Now, with derivative, right side. Can you please mute? So it makes echo, right? So we do product rule f g, which is f prime g plus f g prime. F prime, what do you get?
Secant squared x.
Secant
Yeah.
square x, good. Thank you. So secant square x. And g, which is ln 2x to the 4th power plus 1, plus f, which is 10x. And g prime, what do you get?
8x to the 3rd power.
Okay, that is the chain rule.
Oh, it would be just, yeah,
2x to the 4th power plus 1, right?
yeah.
Okay, so that is, let us simplify. Okay, let us multiply by y, whole thing by y. Okay, so let me write down y there. Then secant square x ln 2x to the 4th power plus 10x. We have, she said 8x to the 3rd power. Okay, what was the y? We looking at the original problem, y equal to 2x to the 4th power plus 1 to the 10x. Then everything is ditto. Okay, we're done. Let me erase.